Dear friends, we have already studied about how knowledge of statistics is important for studying economics. We have also studied about the meaning, types and methods of data collection. Today, we will discuss about how to organize the collected data by classifying them. Classification means arranging things in an appropriate order and putting them into homogeneous groups. Unclassified or raw data are often very cumbersome to handle. It becomes difficult to draw meaningful conclusions from them because they do not yield to statistical methods easily. Therefore, we need to organize and present the data properly to undertake any systematic analysis. Classification is done in various ways depending on the purpose. For example, in a library, the books and periodicals are classified and arranged according to the subjects. Students are grouped according to the percentage of marks they secure in a certain examination. Similarly, plants and animals may be assigned to groups distinguished by their structure, origin, etc. Data may be arranged by time or space or both. For example, we have time series data on aggregate national income, aggregate consumption, size of the population, etc. at different points of time. We have spatial classification of data on literacy rates for different states, yield of crops in different countries and so on. We will discuss about the methods of grouping data on a single variable in details today. However, to begin with, let us consider certain terms which are commonly used in everyday life but have a specific meaning in statistics. Let us first understand what is meant by variables and attributes. In common language, the term variable means certain characteristics that change from one object to other. For example, heights of individuals and their looks change and therefore they are variable. Similarly, the intelligence of people, prices of commodities and incomes are variables. However, in statistics, the term variable is used only if the changing characteristic can be numerically measured. Thus, heights and weights of individuals are variables as they can be measured in numerical terms. Prices of commodities vary over time and space and they can be numerically measured. Therefore, price is a variable. Similarly, incomes of individuals, household expenditure on various items of consumption, size of households, inputs and outputs of firms are all variables. Although the looks of people, their intelligence and aptitude for art and music change from one individual to the other. They cannot be measured numerically in the same way as heights and weights or prices and incomes. Therefore, they are not called variable in the statistical sense. They are called attributes. We may rank individuals according to the quality of attributes. The ranks are sometimes used as their numerical values for purpose of analysis. There are two types of variables, continuous variables and discrete variables. A variable is called continuous if it can take any value in a given range. It may take integral values, for example, whole numbers like 1, 2, 3, etc. or fractional values like 1 by 2, 3 by 4, 7 by 8 or the values like square root of 2 is equal to 1.414, square root of 3 is equal to 1.732, square root of 7 is equal to 2.645, etc., which are not exact fractions. In other words, it can take all conceivable values in a given range. For example, heights and weights of individuals, prices of commodities and incomes of individuals may be treated as continuous variable, although in practice the measurements are taken only approximately up to 1 or 2 places of decimal. The true values may be anything in a certain range. If the variable can take only some particular values like whole numbers, it is called a discrete or discontinuous variable. For example, number of students in different classes or different schools or the size of households are discrete variables as they can take integral values only. In statistics, the word population has a specific significance. Let us understand the meaning and importance of the term population in statistics. In common language, the word population means the number of persons living in a certain region. We may count the number of persons to obtain the size of population of that region. Similarly, we may find the population of certain animals in forests in the country or the population of certain plants in a garden and so on. The term population implies head count. However, in statistics, the data on any single variable or a set of variables for all individual units in a region constitute the population of that variable or variables. If the data are on a single variable, the set of measurements constitute a univariate population of that variable. Otherwise, we have a bivariate or a multivariate population of the set of variables. For example, we may have a bivariate population of heights and weights of all individuals in a region or a multivariate population of expenditures on various items of consumption of all households. Now, we will illustrate the construction of a frequency array and frequency distribution. We obtain a frequency array if the variable x is discrete and we have frequencies corresponding to each value. Here, there are no class intervals. Let us illustrate with an example. A survey of 100 households was carried out to obtain information on their size, that is, the number of members of households. The results of the survey are classified as a frequency array in table 1 shown on the screen. The column 1 of the table shown here gives the values which are variable x, that is, size of the household, takes, and column 2 gives the corresponding frequency, that is, the number of households. Thus, there are 5 households whose size is 1, there are 15 households of size 2 and so on. Thus, the table gives the frequency array of sizes of households. Frequency distribution. Suppose the largest value of x is b and smallest value of x is a. The range is equal to b minus a is the total range of x. A large range indicates that the values are spread over a large interval or the variation of values of x is large. A small range indicates that smaller variation in the values of x. Thus, the range is a measure of variation or dispersion of x. Look at the figure shown on the slide. We can see that the range is a rather crude measure of variation of x. It does not say anything about the distribution of values of x within the range. Are the values of x uniformly distributed within the range as in the first figure, or they are clustered about some values close to the upper or lower ends or the middle of the range as shown in the second, third and fourth figures on the slide. For example, suppose we are considering the distribution of marks obtained by 1 lakh students in mathematics in a certain examination. The maximum of marks obtained is 100 and the minimum is 0. So, the range is 100. It is possible that 70% of the students got marks more than 60 and 20% got less than 40 marks. In another case, 70% of the students got marks between 40 and 60, etc. As another example, suppose we have data on monthly incomes of 10,000 individuals, the maximum of which is rupees 50,000 and the minimum is rupees 1,000. Thus, the range is rupees 49,000. We observe that the majority of individuals, say 70%, have small incomes close to rupees 5,000 and very few, say 2%, have income close to rupees 30,000. In order to get a better idea about the distribution of values within the range, we should subdivide the total range into a small number of class intervals and find out the number of values in different classes. The number of values in a particular class is called frequency in that class. Now, let us see the method of construction of a frequency distribution. While constructing a frequency distribution, one should pay attention to the following points. Number 1, how many classes should we have? Second, what should be the size of each class? Third, how should we choose the class limits? Regarding the number of classes, there is no hard and fast rule about the number of classes, but as a working rule, the number of classes should lie between 5 and 15. It should be noted that the number of classes will be large if we choose small size class intervals, and it will be small if the sizes of class intervals is large. As an example, suppose the range is 70 and we choose classes of width of 2 each. We would require 70 divided by 2 is equal to 35 classes. However, the number of classes would be 14 if the width of each class was 5. However, a frequency table with more than 15 classes will be rather bulky and hence not desirable. It does not serve the purpose of classifying data into class intervals if we choose less than 5 classes. Now, we will discuss about what should be the size of class intervals. We may choose all classes of the same width or of different width. In this case of equal class intervals, the size of the class intervals is determined as soon as we have decided about the number of classes. Suppose n is the number of classes and all classes are of width h, then n into h is equal to r. Knowing the range is r and the number of classes is n, we can obtain h is equal to r by n as the width of the class interval. If the range is 70 and we choose 10 classes, the width is 7. We require that the values of variables are uniformly distributed within any class interval. In that case, we can safely assume that all values are equal to the middle value of the class interval. For example, if a class interval is 10 to 20, all values in this class may be considered equal to the middle value 15 obtained as 20 plus 10 divided by 2 is equal to 15. Using this assumption, the error committed will be small as the positive and negative errors will tend to cancel out. However, the error will be large if the values are not uniformly distributed within the class interval. Friends, now let us understand about how the choice of class limits is made. Suppose x is a continuous variable such that it can take any value in a given range. In that case, it is possible to choose the class limits which are not equal to any of the observed values. For example, heights of individuals is a continuous variable, even though in practice one can measure heights to the nearest of the unit value in centimeters as 165, 170, 169, 171 and so on, or to the nearest of the 10th place of decimals as 165.3, 170.4, 168.9, 170.8 and so on. We may specify class intervals as 160.55 to 165.55, 165.55 to 175.55 and so on, so that none of the observed values of x is equal to any of the class limits. However, if x is a discrete variable which takes only integral values, it will not make any sense in choosing class limits other than the integral values. For example, suppose x is the size of household. We may observe x is equal to 5, 4, 8, 3, 7 and so on in a survey. For the choice of class intervals, we may adopt one of the methods, that is inclusive method or exclusive method. We will now discuss these two methods. In the inclusive method, we choose the class intervals such that both the upper and the lower limits are part of the interval. In other words, the class limits are inclusive. For example, suppose we choose the class interval as 1 to 5, 6 to 10, 11 to 15, 16 to 20, etc. And we find that there is a household whose size is 5. This household will be included in the first class 1 to 5 as both limits are inclusive. Similarly, a household with size 6 will be included in the second class 6 to 10 and so on. In the exclusive method, either the upper or lower limit is excluded from the class interval. Suppose the class intervals are chosen as 1 to 5, 5 to 9, 9 to 13, 13 to 17, etc. and we specify that the upper limit is excluded and the lower limit is included in the class interval. Now, a household whose size is 5 will be included in the second class interval 5 to 9 and so on. We may specify that the upper limit is included and the lower limit is excluded. In that case, the household with size 5 will be included in the class 1 to 5 and so on. Thus friends, today we have seen that once the data are collected, the next step is to classify them for further statistical analysis. We have also learnt about the difference between variables and attributes. We have discussed the continuous and discrete variables. If the variable is discrete and we have frequencies corresponding to each value, we need to obtain frequency array. It should be remembered that the frequency distribution shows the classification of data for a continuous variable. Hope you have understood the meaning and concepts discussed today.